Hello class! Today we are still talking about transformations, which is just how you move or change a figure to make a new figure. So, 4 basic transformations. We've already talked about translations, reflections, and rotations. Today we are going to talk about dilations. Now in those first 3, translations, it just slides it along. Reflection just flips it over. Rotation just turns it. In each case, the shape doesn't change, right? The image and the pre-image are congruent to each other. Those are called rigid motions. Dilations, that's not the case. So let's take a look at a dilation. So with dilations, this is a transformation in which the figure is either enlarged or reduced with respect to a fixed point, the center of our dilation, which in this case is going to be this red dot here. All right, and we have a scale factor K, which is going to be the ratio of the lengths of the sides of the image and the pre-image. Okay, so for example, we said it could be an enlargement. So it could be something like this. So what this is, notice that these rays drawn from the center of dilation pass through the vertices of the pre-image and then through the vertices of the image. Okay, so this is why I say it's respect to the center. Okay. That is how it is drawn, how it comes about. Now, with this scale factor, what that means is we're going to take the ratio of the sides. So 3 and 6, because those correspond to each other. The 2 and the 4 correspond to each other. Now, one thing you got to remember, scale factor is always new over old. So in this case, that would be 6. That's my new. That's my image over the old, which is the pre-image. All right, so like so. So we have 6 over 3, or we could do 4 over 2. Either way, we still get a scale factor of 2. All right, so that's a scale factor. So it is twice as big as the pre-image, as the original. Now it says we could also reduce this. So for example, we could have something like this. All right. So here, this little green one, again, we want to look at our scale factor. It's new over old. So in this case, it'd be 1.5 over 3. Or we could do 1 over 2. In either way, we get a K, our scale factor, of 1/2. All right? And so this is how the scale factor works, and this is how dilations work. You can make them bigger, you can make them smaller. All right? You got to pay attention to which direction you go. Dude, just because it's transformations doesn't mean we're talking about you. No, go away. Yes, go away. There we go. Though that is a lovely demonstration of dilating. Anyways, we are going to take triangle ABC and we are going to dilate it from the origin by a factor of 2. Now first I'm going to do this graphically, then we'll look at it algebraically, which is a lot faster. But just so we can see this. So I'm dilating it from the origin. So I'm going to put in those rays of dilation, and there they are. So the way this works, the ratio is not just for the sides of the shape. It is also for the distance of from the point to the center of dilation. So the scale factor of 2, not only does that mean that our triangle is going to be 2 times bigger than the pre-image, it also means it's going to be twice as far from the center of dilation. So what I can do with this, if I'm here at the origin at 0, 0, point C is at -2, 2. So to get there, I'd go left 2, up 2. I want it to be twice as far away, so I want it to be left 4, up 4. And so that would put C prime is going to go right there. Point B, well, let's see, that would be -6, 2. So I want to double that. I want to go -12, so I need to go over another 6. 1, 2, 3, 4, 5, 6. That puts me at -12, and I need to go up 2 more right there. And so that is where B prime will end up. Let's see, A is at -5, 7. So I need it to be at -10. So 6, 7, 8, 9, 10. And then +14, because I'm going to double the 7. So that would be 1, 2, 3, 4, 5, 6, 7. All right, there. And that's where A prime will be. So all of these are twice as far away from the center as the original was, which puts it right there. All right. And notice that makes this side B prime, C prime, twice as long as side BC. All right. And so that's our scale factor of 2. So let's take a look at the points. And hopefully you'll see this, and you kind of pick this up from how I drew the thing, drew my image there. All we do to get from -5 to -10, to get from 2 to 4, 7 to 14, all we do is we multiply the x, you multiply the y by the scale factor of 2. That's very, very simple. All right, so let's take a look at another one. Here we want to dilate from the origin by a factor of 1/2. So I already drew these in. What this means is my scale factor is 1/2. I want each of these new points to be half as far from the origin. So this one was left 2 up 2. Half of that would be left 1 up 1. Right there. B was left 6 up 2. Half of that would be left 3 up 1. A was at -5, 7, so half of that distance from my center would be 2.5 and 3.5, which puts it about right there-ish. All right, so there we go, A prime, B prime, C prime. Half as far from the center and half the size. This one was 4 units long. Now you see B prime, C prime is only 2 units long. It is half the length of the pre-image. So we can do this algebraically. Here's our pre-image points. Here's our image coordinates. And you see we can do the exact same thing we did before. We're just going to take it and multiply all the x's, all the y's by the scale factor of 1/2. All right, pretty easy stuff. Now, what is a bit more problematic is if we dilate from a point that is not the origin. So on this one, we are going to dilate everything from point B by a scale factor of 3. So I'm actually going to use this vertex right here as my center of dilation. So I'm going to draw my rays in, and there they are. They're the rays of dilation. And we want to make everything 3 times farther away from the center of dilation. So first I'm going to do this graphically, then we'll look at how to do this algebraically. So graphically, let's see here, we went up 5, right 1. We want to be 3 times farther away, so I'm going to do that again. Up 5, right 1, that'd be twice as far. And if I do it again, up 5, right 1, now I am 3 times as far from the center as A originated. So point C was just to the right 4. So we're going to go to the right 12, because it's 12 units from the center. It's 3 times farther than it was before, right? So that's 4, 5, 6, 7, 8, 9, 10, 11, 12, puts it right there. And B, well, B is how far from B? 0 units from point B. It's the same place, right? And 0 times 3 would just be B, right? It's not going to move. And so I end up with it right there. There's triangle A prime, B prime, C prime. All the sides are 3 times as far away, and which makes all the points are 3 times as far away from point B, which makes all the sides 3 times longer. Now let's take a look at this algebraically. So here's our pre-image, here's the image, and you notice it's not just as simple as multiplying everything by 3 this time, is it? -5 times 3 is not -3. -2 times 3 is not 2. So how does this work? Well, the way this works is very, very similar to the way it works when we did the rotation from something that was not the origin. What we have to do first is we have to move it to the origin. All right, so we want to move our center, point B, to the origin. Now you notice that's just a slide. I just slid it over, right? And so that's what we're going to do. We're just going to slide it over, and that would be a translation. Translations are easy enough. All you have to do is subtract that vector, right? And that vector to get from point B at -5, 7 to, point B, there we go, -6, 2, to the origin is just subtract this -6, 2, right? So there it is. -5 plus 6 is 1. 7 minus 2 is 5. -6 plus 6 is 0. 2 minus 2 is 0. Because that puts it on the origin. See, so point B is on the origin. -2 plus 6 is 4, and 2 plus minus 2 is 0. Right there. Okay. Now that we have it on our center, we have it centered on the origin, now we can do the dilation. So we're just going to take our scale factor, multiply everything times 3. Boom. 1 times 3, 5 times 3, 0 times 3 is 0, right? Doesn't do anything. So let's see, can I... No, it's not going to dilate from the center. Of course not. All right. And then, once we have everything there, all I have to do is move it back. So, move it back. I have it dilated, makes it look like that. And now we just move everything back. So we had everything moved down here. We just need to move point B back where it goes. There. All right. So we're going to undo this vector. Instead of adding 6 and subtracting 2, we're going to subtract 6 and add 2, which puts it at -3, 17, -6, 2. Notice it didn't move. And 6, 2. The center of dilation never moves. Wherever the center is, it stays there because it's now 10 times 0 units from the center, half times 0 units from the center. Whatever it is, it's times 0 units away from where it was, which means it is 0 units away from where it was. All right. This is a bit more complicated, yes. Just like with the rotations from somewhere that's not the origin, what you have to do is you have to first translate the whole thing to where your center is on the origin. Then you multiply by your scale factor. Then you translate everything back. All right. And so it's a process, but still it's just adding, subtracting, and multiplying. Not too bad. Pretty easy stuff there. It does take a while. But if you're dilating from the center, you just got to take your scale factor and multiply by your scale factor. That's really easy. One thing I do want to point out, notice that when my scale factor was 1/2, it got smaller. When my scale factor was 2, or over here 3, my image got bigger. If your scale factor is less than 1, your image will get smaller and it will get closer to the center. If your scale factor is more than 1, then your image will get larger and get farther away from the center. All right? And this is not a rigid motion. It changes size, doesn't change shape though, does it? It's the exact same shape, it's just bigger. So these are similar figures. They're not congruent figures, they are similar figures. So hopefully you found that useful. I will see you in the next video.